Alright, good. Awesome. Alright, it's 11:33. We got about 4 people in the chat already. Very nice. Okay. To anyone who's watching that is new here, this is the Vienna Integration Bee. We began with participants taking the qualifying exam, and the qualifying exam gives us the top 16 participants that will be competing in today's bracket rounds. Today we'll be going through, I think, only just like the regular rounds, so like 1/8 and 1/4 finals. All students are undergraduates, and yeah, we'll be starting soon. It's gonna be very exciting. I'll make myself louder in the. Okay. I just have to be careful not to make myself a little too loud. But I can make the background a bit more quieter, like this. Is that good? It's just a little. The background's a little bit loud because everyone's just getting started. Audiences and competitors are just, conversating, getting prepared, getting everything ready. I don't want to make my voice or mic too loud. I'm just kind of far away a little bit, but I am close now. If I talk any louder, my mic is gonna sound very bassy. It wouldn't sound too good if I amplify my microphone. It'll sound very bad. But let me know again if it's still quiet, if my voice is still quiet. All right, awesome. Yeah, the background is just a little noisy. Just we're still getting started. And we got some few audiences now. Wasabi. Welcome to Vienna Integration Bee. I see we got some new viewers here coming. Very nice. We're just getting everything started in prep.
Hello? Is this all right? Can everyone hear me? Okay.
Let me amplify.
So, ladies, gentlemen, and integral lovers, I am very excited, we are very excited, to welcome you all back to Vienna Integration Bee Fall 2024. It's okay.
Yeah!
Okay, so, what is Integration Bee for those who were not here last year? We can move to the next slide. So, long story short, Integration Bee, just like past students, were also founded by students at MIT in 1981 by a student named Andy Burnoff, who thought, can we make math a sport? And the answer is yes, we can. So, this is what we did. We put people fighting on integrals one-on-one. Each one gets a board, actually 2 boards, and the timer, and whoever gets the integral first moves on to the next round, or at least gets 1 point. Okay, now let's move on to the sponsors? Yes, the sponsors, because as boring as this is to some of you, we really have to thank them, because without them, this would not be possible. First and foremost, obviously, we want to thank Pepsi. If you can see, there are two Pepsi can-shaped, Pepsi can-filled fridges at the top. One with normal Pepsi and one with sugar-free Pepsi. So take as many as you want. They are for free because Pepsi decided that they love STEM students and they want to help us. Okay, moving on. We have Foromine. Foromine is a software development company from Poland, up and coming. It's a startup, and they helped us make our new website. As if some of you noticed, we have a new website that looks completely different and operates on a different system. And they also made our integral software, with the help of which we will present all integrals that you will see today. And it's a very, very nice, and we really appreciate their effort. They really wanted nothing in return except for being shown here. Next but not least, we have Smarakis. Smarakis is an accounting and IT support company from Vienna, and we are very thankful to them, and I think the contestants will be very thankful to them, because they sponsored all except one of our prizes, which you will see tomorrow, which are all gadgets in a form or another. So we want to thank Smarakis very much. And now we move on to who made this event. First and foremost, the biggest loss of this event is Max. You might recognize his face. Maxim Czarnecki is an AI developer. He's a student at this university. Sadly, for personal reasons, he could not make it to this event. But he is part of the heart of this event. He ran all around Vienna begging people to give us stuff for free. He did our first website for the first event in May, if you remember that event. And he did so much more. And we are very thankful to him. And I think he is watching upon us, and I will tell you in a second why. Moving on, we have me, nothing important there. I also study here, I study math, that's it. Then we have Konsti. Konsti is right there, and I think he deserves a round of applause.
Oh no. That's not good. Refresh a little bit. There we go.
It would not have happened without him. Last but not least, we have a newer addition to our team. You might recognize him from the semifinals of the previous event. Adrian Weissender right there. Maybe you remember a specific round in which an integral was shown, and then he just ran to the board and wrote 1/2025, and it was correct. Well, he is a great integral solver, but he said, maybe I can help you more, and he decided to join our team in the back rooms, and now he constructed a big part of the monsters, but also the friendly integrals that you will see today and tomorrow if you will join us. So thank you a lot, Adrian. It should be mentioned that all the integrals that will be seen in this event are absolutely original. They might be inspired from other events, but this time none of them is copied, even from a very unknown integration bee. All of them are 100% new, even though they obviously contain functions which you should all know. Moving on to the rest of the team, we
seem to have.
We have Jonas, who is very focused, and he's going to be our photographer. He was also our photographer last time. He's currently laughing there in the first row, and you better hope he's going to take nice pictures for you. Speaking of that, because we have to be fair and square, if any of you wants to not be taken, wants pictures of him not to be taken, then please let us know, or let Jonas know right there, and we will try to avoid that if that makes you feel uncomfortable. Moving on, we got Silver. Maybe some of you recognize the picture, maybe you don't. Silver is an integral YouTuber who just solves integrals for fun and integrals from integration bees all around the world. And right now, he is live commenting this event as we speak, which is transmitted live on our YouTube channel, just like a football match. So if you have some friends who couldn't make it here, they can go and tune in on that stream and they will hear Silver's voice.
Oh no, we are
commenting on this event right now.
Some difficulties.
Texas, they are also part of our integral team because we have expanded this time. They helped us write many of the integrals which you will see. So if you love them, thank them. If you don't love them, don't come at me. Okay, moving on. We have some special thanks. Of course, we have to thank nominally Teresia Eisenkörper. She, on this event, last time, but also this time, could not be possible without her. She helped us pull the strings, she helped us do a lot of stuff which we couldn't have done. Obviously, because we have to be fair, we have to thank the university. After all, we are all inside of it. By the way, all the rules that are written on the board, on the door outside, are on top of the rules which you already and we already have to respect just by being in this institution. So I will ask you to please abide by those laws because we don't want any repercussions. Next, we have actually a contestant, but I promise he knows none of it because they're not here. I really want to thank Erik Bramberger personally here from the stage because he is the one who actually got the room in which we are right now. He's the one who did a lot of things which sadly we couldn't do this time. So I thank Erik very much. And you can applaud him after. I will also thank the winner from last time, Georg Weissbier, who did very similar things in a very similar manner. And definitely
if this screen gets a little too laggy, we do have a second backup to switch to. But for now, this one may be a laggy and might have to switch to a different screen.
Okay.
Yeah, so no, the phone is.
Okay, next we have our volunteers. That would be Zeno, Laura, and Sarah who are right there on the cameras, and also Victoria who's going to help us.
Because I'm full screen.
Tomorrow as well. They basically gain nothing. They're just here because they love integrals or they love people or just because they are good people. So I think they definitely deserve a round of applause as well. Okay, moving on.
Just pull that up
This
just in case.
is
Because this is really lagging.
bit random. For those of you who don't know, next year there will be 100 years of quantum mechanics, and those three things behind me were discovered roughly 100 years from now. And this is not just a random fact, because our special secret prize for tomorrow might have something to do with this. And now we move on. We get to the rules and structure, and I know this is a bit boring. But I have to explain. First of all, we have 8 finals. You can see them already drawn there. Of course, we don't know yet what the matchups are. The 8 finals have to be kept simple because there's a lot of them, so it's just going to be a best of 1 thing. That means the first one who solves an integral moves on. It can take 5 integrals, it can take 1 integral, it doesn't matter. The first one to get the correct integral, the correct answer in the correct amount of time, will move on. Also, we have a special category of tiebreaker integrals, which are comparatively easier to given the 8 final integrals. And if enough 8 final integrals in one battle have not already been solved by any of the contestants, we will hand them tiebreaker integrals. And they work just the same. So if you get it, you move on to the next round. And then we have the quarterfinals, which you can also see drawn there. Of course, we don't know yet who will be in the quarterfinal. But we know that in order to make this event more fair and square, and for someone to not go through just because maybe they remember this integral from a website, the quarterfinals this time are best of 3. And not exactly best of 3, but most out of 3. That means if we give you 3 integrals, and one guy solved 1, and the other solved none, then the guy with 1 integral moves through. So you don't need 2 out of 3, you just need to have most out of 3.
And we thought,
Okay.
what can we do with 15 contestants? That means somebody should go straight to the quarter.
Also, I guess, emotional to the contestants. We will have the brackets.
Oh.
And what did we do this time
one's
is that
playing
we
now.
didn't have a preliminary test because we had exactly 16 people. Then we lost some, we won some along the way.
I'll close that
and
for now,
we
just
ended
in
up
case that we
with
don't overlap.
15 contestants. And we thought, what can we do with 15 contestants? That
Go
means
through that
somebody
again.
should go straight to the quarterfinals. And we thought, in order to reward meritocracy, and I would say it's also quite fair, we decided that the winner of the previous event will be automatically playing in the quarterfinals. That will be Georg Weissbier. That means in the first pairing right there will be Georg written and nobody under him. And then we have 14 names, which are currently in alphabetical order, waiting on a list on random.org to be shuffled once, and then in that order they will be written down in the rest of the brackets. So let's do that. Okay, those are the contestants in alphabetical order. That is the order. So we have Kur against Birbalmer in the second matchup there, which will actually be the first matchup. Then we have Vesna against Pultar, Shi against Rusti, Sheket against Eagle, and so on. Also, because we were informed of this little thing before the event, the 8th final, I forgot to mention this, the 8th final in which Gary will participate has to be the first one, right, for logistical reasons. So we will start with that, and then we will go as the board is going. So then, if I'm looking correctly, we invite to the board Kerry Gramberger and Severin Komic. You can applaud them, you know, they have a lot of courage.
All right. Alright, so since we will be starting our first integral. So just to recap, anyone new here, thank you for joining with us. This is Vienna Integration B. Oh no. I really hope this doesn't... Oh, let me... I'll keep it a delay.
Okay.
So that it has time to load.
This is our software. Don't worry, when the integral will be shown, the white thing will not cover the board, which was a problem actually at the last event. Which was a problem actually at the last event.
There we go. Just kind of do a 5-second delay, and then so that the live stream has time to load. I think that should be good now.
Okay, are both of you ready?
Alright, we'll go ahead and start our first integral here.
And we shall start.
Here we go. Alright, so they're starting off with the integral of sine of x over cotangent of x times tangent x over cosine of x. Alright, so left one seems to be already trying to simplify mentally. Just kind of writing out references. Okay, good. So if you guys notice, this is technically the integral of tangent cube, if you simplify it. Oh, are they? Okay.
Small mistake, we didn't stop the time, but there was like 2 minutes and someone discovered. 30 seconds, okay. So we have to check the answer first.
It looked like tangent cube. Yeah, I figured, because it's not exactly tangent x, it's tangent cube. The cotangent doesn't really cancel it out. If you look very closely, notice that the cotangent is at the bottom. So yeah, I don't blame. It's a very when you're rushing like that, it could be you have to be very careful with accuracy, especially when you're integrating very quickly. Right now, the person on the right just try to simply make sure that they don't get anything wrong. Just kind of make sure they simplify it nicely. Tangent cube, you're gonna have to turn tangent square into secant square of x minus 1. And then u sub on the first term, integral of tangent x on the right term. So you should end up with kind of like a half tangent square minus ln of secant x, I believe. Right now the person on the right is just trying to simplify, turning everything in terms of sines and cosines, I believe. Yeah. The person got something like sine cube over cosine cube. I would probably turn everything in terms of tangent and secants. This person's trying to kind of find a way to do it in terms of sines and cosines, but if it's like awkward, especially when there's like a cosine in the denominator, I would recommend just converting it in terms of tangents and secants. It would be very difficult to kind of integrate in terms of sines and cosines because you have the cosine cube at the bottom. It'll just be awkward. It probably would. It's possible to integrate it in terms of sines and cosines. It'll just be very awkward to integrate it in that type of term. It's just a lot easier and quicker to just convert it in terms of tangents and secants. Yeah, it would just be a little awkward
And
kind
time.
of format it.
Okay,
That's
we
time.
don't have an answer, so we will show the official answer.
Oh, half secant square of x plus ln of cosine of x. As you can see, definitely don't rush and don't do mentally as I did. But I don't blame anyone. That was a good first start of the integral. Yeah, keeping it in terms of sines and cosine would be very awkward to integrate it. Because of that cosine cube at the bottom, I'd turn everything, convert it, everything in terms of secants and tangents.
Are you
Alright.
ready? Alright, let's go.
Alright, to our second integral. We have the integral of tangent of x over 4 over secant of x over 2. Very interesting. I would simply turn everything in terms of sines and cosines just to get a good feel of what is going on in the integral. Right now, let's see, person on the left is thinking about trying to u sub. That's also a good start too. You can let u equal x over 2 or x equal, let u equal x over 4 just to get the constants out of the way and to see the integral in a nicer form. Person on the right is just trying to kind of trig manipulate, I believe. Both are really trying to kind of using different experimental ways to integrate this. We have cosine square minus sine square. Our tangent of x. Okay, so so u sub and then kind of try to form everything in terms of sines and cosines. That's actually a great start. You know, it's easy and it's simple, so you don't have to lose track of anything. You're not really overcomplicating any techniques here. The person on the right is, I believe, still stuck in terms of x over 2 and x over 4. It is very distracting. So u sub was probably a good way to go, especially if you're not kind of too comfortable with trig identities. The person on the left seems to be stuck trying to integrate tangent of x and sine square. It is an awkward looking integral if you don't know what you're doing. You're gonna have to kind of split that sine cube up if you want to integrate sine cube over cosine of x. Because that cosine of x is really like not exactly distracting, but kind of blocking the way of progress. But he's trying to do that right now. He's trying to figure out a way to manipulate that tan x. It is very awkward. The person on the right is still kind of stuck trying to manipulate the integral. It is a very awkward integral too. If you're not very comfortable with, you have to be very manipulative. Oh, and we have an answer. Sine over x over 4 minus ln cosine. Is it cosine of x or cosine of... It's missing a parentheses inside. Yeah. X? I can't even tell. It's hard to do it in head. No, incorrect. Incorrect or time. That is their answer. It is very tricky if you don't know what you're doing. The person on the left did a very great first attempt is letting u equal x over 4 to get that out of the way, because it could be that x over 4 could be a little distracting.
Tiebreaker.
Alright, we'll get to tiebreaker. So again, these competitors, you only have like one try. There's no. Technically you only have like one guess. And you're done. So you have to keep that. You have to be very accurate. You know, no room for mistake.
Are you gentlemen ready?
We're gonna start a tiebreaker.
Let's go.
Alright, here we go. Ooh, the integral from 1 to infinity of 1 over x square root of x cubed minus 1 dx. It's a very, very popular integral. However, that x cubed is very deceiving if you don't know what you're doing. U equals 1 over x. The person on the left is attempting inversion. That's one good start. However, the bound is... Oh no, I think it should be still good. I don't know how it would help exactly. It's a good start. It's a good experimental start, but I mean, it's 1 over x cubed minus 1 inside the square root could be a little... I don't know how you would kind of maneuver that. There's probably a way to maneuver it, but it'll just be a little awkward to handle. Person on the right is still trying to think of a way for writing something. I would most likely try. It's weird to do trig stuff because you have that x cubed, so you need to do something with that. That's the sneakiest part about this integral. So I don't blame any of these contestants. Right now, the person on the left is really trying to manipulate the integral using inversion. Yeah, I would retreat if or not. Let's do 1. I can't tell. Person on the right is trying to find a way to kind of algebraically manipulate that, right? Because that x cube is really distracting. It is a very tricky integral if you've never seen this integral before. It is actually very, very sneaky. U equal e to the x. That's a very creative way to get rid of that x at the bottom. Letting u equal e to the x, or sorry, letting x equal e to the u, or e to the t. That's what the person on the left is doing. That's actually a very creative way to get rid of that x at the bottom. Unfortunately, you still be left with e to the cube t in the radical. I don't know how you would deal with that. Alright, putting it in. I believe the right person on the right is trying to do partial fractions. Looks like. Oh, pi over 4. Close. I think it's pi. Is it pi over 4?
That's wrong.
Okay.
4 seconds left, go.
Very close though. I think the answer is pi over 3. Negative pi over 4.
Okay,
No.
time's up. The answer is...
Yeah, I think. Yeah, it's very, very close. Both were very, very close. It was a very good guess. Very good guess. Unfortunately, it's pi over 3. Very good guess. Yeah, when in doubt, when time's about to be over, the best thing to do is just make an educated guess. Last resort. Very close. Off by an integer, that's crazy. But yeah, it was a very tricky integral if you've never seen that before, you know. It was, it's pretty much it's like a sneaky form of inverse secant. One way is another way is like to multiply x squared top and bottom, but then u sub x cubed minus 1. But it's very tricky if you've never seen it before. So I don't blame any of these contestants. So I think we're gonna do another tiebreaker.
Alright, let's go.
Alright, so now we're starting. Ooh, 3 to the x over 1 plus 9 to the power of x dx. Alright, now they're just they're just writing it down. How fast would one of them catch it? Mu 3 to the power of x. Oh. Person on the left might actually get it. Just don't forget the ln of 3. Oh! Person on the right seems to have the correct format. Just don't forget the ln of 3. Oh, that looks correct. Oh, come on. Oh, right before. Oh!
Oh.
That looks correct. ln of 3? 1 over ln of 3? Yeah. Inverse tangent of 3 to the power of x.
That is correct.
Yeah, nice. Wow. Came in clutch. Oh no, it's buffering. There we go. Buffing a little bit. Okay. Might have to probably time back. Oh, we good? Clear. Alright. That was a very good first match.
And we call the board Kur and Gilbauer.
Yeah, so right now in this round, it's only best out of 1. Whoever gets the integral correctly gets to move on to the next round. So yeah, right now we're just doing 1/8 final, 1/8 finals round. So just the best of 1. So it's very, very pressuring. Ooh, we got 26 people. So again, just to recap, you know, these are top 16 participants in Vienna Integration B. All students are undergraduates. We're just doing 1/8 finals, regular round, 3 minutes per integral, and you know, these competitors, they only have one guess. Only one guess. Best of 1. So it's very, very, very pressuring. Right now we're just getting ready for the next integral.
Ready? Alright, let's go.
Alright, here we go. Inverse tangent of tangent x. That looks like a tiebreaker integral. Is that? Yeah, it looks like I don't think this integral is supposed to be.
The answer is wrong, you can continue.
Oh, okay, it's not tiebreaker? Okay. It's not x squared over 2. Oh my god. Yeah. No, be very careful. Integrals like this. This is also, honestly, my annoying types of integrals to deal with. Because you really have to consider the domain of the function. So it's very tricky if you don't know what you're doing. Yeah, x squared over 2 is not the correct answer. Because that's not always true. Just trying to figure out. Graphing was a good first approach, but only do it when you have a very good understanding of functions very quickly. Oh, is he trying to split the domain? Wait, but why is there... What's the bounds? Oh, the bounds variables. This is using z, f of z. Pi square. Interesting. This is a very tricky integral. My safest bet is to do integration by parts. If you ever stumble across an integral like this, integration by parts. I know it sounds weird, but it is the safest thing to do. This person is taking the min of a function. Try to understand the domain restriction in this function. Which part to integrate, which part, you know. Pi square over 8. Is that just going to be left as a constant? 30 seconds remaining. What is that? Something plus pi over 2. Kind of see where the direction is going. Oh, or not. No. I don't blame. This is very tricky if you don't know what you're doing. You have to be very careful with the domain. It's a very tricky integral. Yeah. Integration by parts is the way to go. It's the safest thing to do, especially integrals like inverse sine of cosine of x. Like that's a very common popular integral. Like, integration by parts is the safest thing to do. It's a weird form of answer. I don't know if they'll accept that. I don't know if they're going to accept that answer. Right now they're trying to judge if it's acceptable. I don't know. It's a weird form. I don't know. I don't think they'll... Right now they're just kind of considering. Yeah, no, it's a very tricky integral. You have to be very considerate with the domain of the function. Yeah, right now they're just trying to. The contestants just trying to explain. Yeah, I don't know. I don't think they'll accept that form of answer. X squared over 2 was a good try. But unfortunately it is a very evil integral. I don't even like those type of integrals. It's very, very evil to pull. But yeah, I don't think they're gonna accept that. Well. Can we get these questions after the event? I mean, we're live. I mean, this is a live stream.
So because we already have two-way final integrals, we're going to give them a tiebreaker.
Okay. So when I do a tiebreaker. But going back, this live stream should be saved, so you should be able to go back and have the integral questions. Oh no, it's buffering a little bit. Go back a little bit. There we go. Kind of let the live stream load in. There we go.
Ready?
Face test.
I just can barely read the questions. It depends on the organizer. Right now we're having a tiebreaker integral here. Integral from 0 to 1, x inverse tangent x squared. Yeah. The immediate thing you should do is u substitution. And then... But I don't think any of the... I don't see anyone doing u sub. I would u sub quickly and then try to see where to go from there. Inverse tangent squared. Oh, the person on the right did u sub. Yeah, and then after that, you're just gonna have to do. There's two ways. Either you use integration by parts, or you could do a forced u substitution. Oh, is that the person on the left is my? Okay, I was about to say Taylor series. That's. I mean, it's possible. It'll just be very difficult to kind of perform under 2 minutes. You have to be very careful with like constants and juggling around with constants pretty much, and then solving the sum. And you have to keep in mind that's a squared inverse tangent, so I don't know how that's gonna work. And the person on the right is trying to integrate by parts. It is a very awkward looking integral. I believe he is trying to integrate by parts on the right side. Yeah, he's integrating by parts. The person on the left is trying to experiment whether putting in exponential form would help. But it's inverse tangent, so it should be. Oh, okay. I think the person on the left is trying to find the logarithm form of inverse tangent, maybe. That's gonna take a while. 35 seconds left.
30 seconds.
So great start. And then both of them did u sub, getting that x squared out of the way. But the inverse tangent squared is a very tricky integral because it is awkward to deal with. Inverse tangent is very awkward to deal with if you're not too comfortable with the function. Ooh, 5 seconds left. Pi over 2.
Oh. The answer is wrong.
Good guess.
Do you want to start the answer as well? You have 2 seconds.
0.
The answer is also wrong.
Pi squared over 24. Yeah, integration by parts was a way to go. However, you have to be
Now we're
very careful. It was a tricky integral, I will say. That is a very tricky integral. You have to be very comfortable with inverse tangent. The answer does look like something to do with Taylor series.
Well, ready? Let's go.
Alright. Oh my god. Don't get problem shock. Do not get problem shock. There you go. Yes, please. Immediately, if you start somewhere, right? The person on the left did a great job. Just immediately just try to rewrite the integral and try to see where to go. The person on the right try to find a u substitution, but I don't know. Those polynomials are very. They're not so friendly. But it's a very good start with the u substitution. Maybe a blind substitution, but I can't really see that. I don't know how that's gonna fit. Yeah. Unless he notices something. That is a very tough integral. How would you even go about this, actually? Everything's in squares, so maybe kind of caveman trick or square technique. But that's very hard to see. Very hard to see. Wow. Even if you control the numerator, like notice like, oh, we have x4, x squared, and then a constant similar to what's inside the radical, you're still gonna, you have that x to the power of 6 at the bottom. It's very awkward, very weird. Right now, they're just trying to figure out an idea of how to approach this, because it's a very awkward integral. Kind of extreme, actually. It would see. Just trying to kind of reformat the polynomial, maybe factor it in some sort of way. There could be a possible u substitution, but I don't know how.
30 seconds.
Keep in mind, this is an indefinite integral, so it's difficult to kind of cheat with the bounds when there's no bounds. Dang, in 10 seconds. I don't even know where to begin. I would just start experimenting with caveman and square technique. It's a very unfamiliar trick. Yeah, I don't blame it. That's a very hard integral. I'm curious to what the answer is. Solution. Wow. That is tough. That's a very hard integral. I think that does come from caveman trick. That's a very hard integral. I think we're getting a tiebreaker now. I think they're gonna do a tiebreaker integral. Or probably here we go. We have a lot of inverse trig functions. I know it's buffing a little bit. Just kind of back out. Notice that inverse sine and cosine of x is being added. I would kind of take advantage of that, but it's not always a common known identity for everyone. So I don't blame. But I would start integrating by parts with every inverse trig function. 1 over cosine of x. I don't think that's what the function is interpreted. Unless they go by the notation of arc. Oh, is the person on the right also? Okay, maybe they do use the notation of arc, because I'm used to just calling this inverse trig. Pi x. Wow. I would be amazed if that's
correct.
wow. That is crazy. Pi over 2 and the other is also pi over 2. Yeah, inverse sine plus inverse cosine is pi over 2, and then I guess inverse secant, inverse cosecant is also equal to pi over 2 as well. That's crazy.
Okay, so we had the final pool.
That was a
Again,
very nice.
The pool went through, but obviously more deserve a round of applause. And now
Wow.
we invite Josef, Lesna, and Tommy Pulvar to the board.
That was very surprising. I actually would have not known that. I only know like the identity for inverse sine plus inverse cosine. I would have never. That was very nice. I think the entire time that contestant was just kind of testing and thinking, does it really equal to pi over 2? That was very, very nice. It seems to be a little lagging a little bit here and there. Oh, would you like 5-second delay? Just help the live stream to load in a little bit. Oh no. Oh, there we go. Oh no. We are having some technical difficulties. Oh. And there we go. Oh wow. Starting off with piecewise integral. Integral from 0 to 1. The maximum of inverse cosine, inverse sine. Wow. Starting off with a piecewise integral. Piecewise integrals are very difficult because sometimes you're kind of forced to graph and you have to have a very good in-depth knowledge of concept for the functions. Right now both of them are graphing, try to find which parts is the maximum. They both graph very quickly. I'm impressed. That was a very great start, you know, for an integral like this. You have to find the maximum and then you have to split the bounds at a point where the maximum is different. The only tricky part is where does it split at? You just have to find that certain point where it intersects. Both seem to kind of struggling where to find the point to split. Oh, 1 over root 2. That seems right, actually. 1 over root 2. Well, the person on the left might get it. That actually looks correct. Now you just have to integrate by parts. And doing that in less than a minute. Yeah, you need to be fast with your toes. Integrate by parts on both of them. And that's simultaneously computing the bounds.
30 seconds.
It's a very difficult integral to speed integrate. You have to be very careful. U cosine of u. Oh, that's one way to do it. They both have 10 seconds left.
Time's up.
Yeah, that's very hard to speed integrate. You have to be very careful with everything. 1 minus root 2 plus pi over 2. Wow.
We continue with the second.
Yeah, piecewise integrals are very difficult. sometimes they're kind of forced to graph, and you have to find an intersection to where the bound splits. That was a very difficult start. We'll go ahead and get ready for the next integral. Alright, and we have the integral from 0 to pi over 2. 1 over 1 plus tangent of x 3x. Oh. I appreciate for all you guys bearing with us. I just got a message. Their internet at the university is not the greatest, but it's okay. We all can relate. Right now, one of them is quickly trying to. Okay, u sub let u equal 3x. Very good. Great start. You know, get it out of the way. Person on the right is trying to trig manipulate. This is a very tricky integral. Cosine. Arcsine of u. What did the person on the left do? This is technically, it's one of those sine over sine plus cosine integral. But I don't know what he did. 1 over x du. It's kind of hard to follow. I don't understand how. Outlet of 2 over 3. Wow. That actually looks legit. That looks like a legit answer. No, incorrect. Yeah, now it's all up to the person on the right. He's trying to kind of trig manipulate somehow. Oh, shoot. So he's using the identity of sine 3x and cosine of 3x. I just realized that. Oh my god. I mean, you could, but it's very risky to do that. Especially under a minute. That's very risky. It's a very risky thing to do. I don't know how you would go about it very quickly. I'm not sure.
30 seconds.
Oh my god. Multiply. Oh, okay, so he's using a different approach. Pi over 2.
An answer which is also wrong.
Dang. With 7 seconds left. Pi over 12. Very close. I believe it was like 1/3 times pi over 4.
They still deserve your applause. They're very brave to be here.
Yeah, it was a very, very great. Wow.
And as before, we will now.
Again, very tricky integrals too. Like these has been very tricky integrals. Just kind of get the latency. There we go. It's lagging. It's buffing a little bit. But no, that was a tricky integral if you've never seen it before, because you'll be left with a cosine over cosine plus sine of x. It's one of those very tricky trig integrals. But yeah, no, good attempts. Oh no, it's lagging very badly now. I might have to push it to 5-second delay like that. There we go. We should be good to go now. That was a very tricky integral if you've never seen that integral before. But
Let's go.
we'll start with another integral. So there we go. Oh no. Come on. Oh my god. Oh, we need to do 5-second delay. There we go. So that's a very scary looking integral. Yeah, start simplifying as much as possible immediately. Try to kind of oh no, it's lagging very badly. Do another 5-second off delay. But wow. No, they just wrote the integral, rewrote the integral. But yeah, I'd start simplifying some things, just kind of see where this integral kind of leads us to. The person on the left is trying to let x equal cosine of u. Interesting. X equal cosine of u. How does that work? Because you have the inverse secant in the way. Oh no. This is buffering way too much now. Oh no. It's lagging a lot more often. We might have to go in case. There we go. Again, we have a backup live stream, except that it's not on YouTube, it's on a different website, so it's just gonna just bear with us. Yeah, that inverse secant is really like out of the way. I don't know how u x equals cosine of u. I don't know how that's gonna work. How would you go about this? Notice the denominator, there's square root of x. You can factor that out, so you get like x. And then you're left with x squared minus 1 squared. So I think doing trig sub is probably the best bet. Let x equal secant theta. Yeah, they have like less than a minute left. X equals secant theta is probably the best starting point to go and see where that flows. Just on the left, still trying to figure out substitute it with cosine, but I don't know how that's gonna.
30 seconds.
Yeah, I don't know how that's gonna work. That inverse secant is really out of the way. Oh, person on the right has an idea. Ooh, 10 seconds remaining.
Time's up.
Dang. Inverse secant of x over 1 minus x squared. That's a quotient rule integral? That's evil. That's a very evil integral. I wasn't expecting it to be a reverse quotient rule integral. Wow. That was a very, very sneaky integral. Holy hell. Yeah, I wouldn't even be able to kind of know that. But I think x equals secant theta was probably a good first approach. Alright, next integral here. We have a pi product. Wow. From 0 to 1, ln of cubed. And we have a pi product from n equal to 1 to infinity. X to the power of n square, I believe. N square? Or is it n to the power of negative 2? Yeah, I believe it's x to the power of n squared.
-2. That's an error.
Oh, that is a -2. Okay. Yeah, it was a little hard to see.
N to the -2 at the top.
Yeah. Okay. Wow. High product. So, yeah, that's a very great start to do. Is turn it into a sum, see where this is. Now it's just in terms of integrating from 0 to 1 ln of cube. X equals e to the u. Oh, he might get it. Does he? Would he recognize the gamma function? That's the question. And if he does, then oh, so close. Right track. You got the very right track. Oh, is he missing a constant? Pi square over 12. Where did the half come from? So close. Oh my god. It's in terms of gamma. I mean, it's integration by parts. You could do that too. No, he's just right there. I think he's just double checking if he's missing any
30
constants.
seconds there, but because of the mistake,
Pi square over 2. Where did the half come from?
So 1 minute left.
Yeah, the person on the right also got it too. Pi square over 6. That's just integrating by parts. And then the person on the right is actually integrating by parts very quickly, actually. Oh, they're so close. Both of them are so close. Both of them are very close. Dang. Time is up. Oh. Are they... Guess they're still going. They're given a chance to kind of... They're both very close.
You got an answer and that's wrong. You
No.
have
Thing. No,
30
0.
seconds left.
No. Oh, what's... Oh, okay. There's something wrong with it.
And
Dang. Negative pi to the power of 6. Oh, because it's ln cubed, so you have to cube. They forgot to cube the pi square over 6. Dang.
we go to the next
That's
slide.
evil. That is evil. But they were both very close. That's a very sneaky. You have to be very, very careful, especially when you're trying to, in a time limit. Sometimes when you go fast, you can miss a constant or a negative. Accuracy. So that's very tricky. Oh, we're buffering. Alright. Oh no. Let me go like that. There we go. Integral of cosine square 3x over 1 plus cosine 3x. Wow. This one's actually, yeah, I'd let u equal 3x. Get that out of the way. Yeah, let it prevent you from distractions. U equal 3x is a very great start. As you can see, that person on the left is trying to oh, cosine square 1 plus cosine u. Cosine u. Oh, no way, but he forgot the half. If he's... Oh, no, no. Okay, never mind, never mind. No, he's doing polynomial division. Okay. That's actually not bad. You just have to integrate the cosine over 1 plus cosine of u. The person on the right is just trying to graph, see how. I mean, there's no bounds, but I'm not sure. They're both at a very good format right now. Like, just they're both at a very good integral format. Not just in terms of integrating 1 over 1 plus cosine of u, or 1 over 1 plus cosine of 3x. The first two terms. This is still trying to find a to graph it. Ooh. Oh my god. In less than 1 minute. Who's on the left trying to do Weierstrass? That is one way to do it. You can use Weierstrass. You just have to be very extremely careful not to miss anything. You just have to be very careful, but it should simplify very nicely. Yeah, the person on the right got the first two terms. It's just a matter of the third term, how they're gonna integrate it. They have literally 15 seconds left. Ooh, 10 seconds left. Oh, they're both very close. They actually started off very good, but not enough time. Yeah, that last term of the integral was a little tricky to them. It threw them off. Yeah, the easiest way is to kind of conjugate it. Multiply top and bottom by 1 minus cosine of u. But it was a good attempt. Second person had an answer, but it's in a weird, awkward term. That actually looks kind of correct. Tangent of 3x over 2. That looks correct, actually. But I'm not sure. Right now they're checking if the form of the answer is correct.
The answer is wrong. 2 seconds.
Oh, the answer was wrong. 2 seconds left. Dang. Yeah, there's no way. It was a good attempt. Yeah. Very good attempt. They started off very strong, actually, but the last term was confusing. All they had to do was multiply top and bottom by 1 minus cosine, but it was a good attempt. Weierstrass was actually... you could also use Weierstrass as well, but you just have to be very quick on your toes because you have to write a lot more. So it was a little risky, but dang.
Okay, next tiebreaker.
Alright, next tiebreaker integral. Just erasing the board. Wow. next integral. Another tiebreaker.
Okay, let's go.
Alright, here we go. Ooh. Dx over x cubed plus 6x squared plus 11x plus 6. I believe that does factor. Yeah. Person on the left is factoring right now. X squared? Yeah. Very nice. Now it's just a matter of doing partial fractions. They need to get that factored right away or quickly, because they'll have like about 2 minutes left, and they're gonna need to partial fractions. Yeah, they need to do it very quickly. They just have to be very careful with constants. Make sure you don't get any constants left behind. So while rushing, you have to be also quite accurate. Yeah, accuracy is very important. Yeah, right now the person on the left is trying to quickly partial fraction, try to decompose the function without making any mistakes. Because again, like, you only have one try, only one guess. Ooh, letting u equal x plus 2 is actually one way to do it. That's actually not a bad idea. Letting u equal x plus 2 is actually not a bad idea. Dang. One minute remaining. Yeah, you have to. This is a very a speed bashy integral. Actually, you have to be very quick and accurate at the same time. Try to get an answer before the time stops. Well, I think he got all the coefficients.
30 seconds.
Now he just has to write down the answer. He has 30 seconds left. No coefficients, just all ones. Yeah, I figure there should be some constants. Oh.
Oh.
Dang, and 5 seconds left.
The answer is wrong.
Dang.
5 seconds.
5 seconds left. Yeah, there's auto. That's a very speed bashy integral. You have to do partial fractions very quickly. Yeah. The half of the ln of x plus 1. It's a very speed bashy integral. Yeah, very close. Person on the left was very, very close, but missed somewhere. Made a mistake on the coefficients. Yeah, that's like the most dangerous thing, is you have to be very careful with coefficients. You can make a mistake very easily. Wow. Quite tough, actually, to speed bash that integral.
Ready? Go.
Alright, here we go to the next integral. Oh wow. Cubed from 0 to pi root 2. Yeah, start simplifying. Don't get problem shocked. Yeah, I'd start simplifying everything. See what is going on. Notice that you can factor the secant x at the bottom. Cosine square. Oh, did he accidentally cancel out the cosine and secant x? Okay, cosine square, very good. I'm glad he caught that. Yeah, be very extremely careful. I'm really glad he caught that. Yeah, start simplifying and see where it's going. Notice that the denominator is very similar. Right? What happens if you multiply both denominators? We end up with 1. So there's some simplification here happening inside that cube. Person on the right is trying to figure out a way, well, simplifying it in his head, kind of reforming the integral. Right now he's cosine cube, sine cube. Now you just have to kind of use trig identities and u sub. That cosine cube. You gotta take that cosine square out and turn it to 1 minus sine square and u sub it. I know it looks very distracting. Sine cube and cosine cube. So close. With under 40 seconds left. Wow. The person on the left is like very close. Very close. The person on the right is just trying to reform it. Oh. Are they cosine square? Cosine cube? dx? Dang, so close. 2/3. Wow, the person on the right actually had the correct integral format. Just so close. Very close. The person on the left messed up the algebra somewhere. Yeah, very close. The person on the right had the correct integral format. It was just the amount of time. So close. 2/3 just comes from, if you use Wally's product, sorry, not Wally's product, Wally's trick. You get the answer fairly quickly. If not, just do a U sub. But dang, again, so close, very close.
Give you another timer. Ready?
Alright, go for the next integral. Wow. Integral for log sine inverse tangent x. We'll kind of reformat that sine inverse tangent x. Use the triangle if you need to. Yeah, but U sub also helps. If you're not comfortable with the triangle, you could a U sub also. Or not a U sub, but just kind of manipulating it. Yeah. X equal tangent of U. Yeah, U sub also works. Just try to find a bigger picture. Arctan equals arc sine of x. Interesting. Chris on the right is trying to reformat it. X200. That looks like integration by parts. Oh no. Okay. No, so the person on the left is doing U sub, and then you end up with secant square log of sine. But yeah, that's why I start using integration by parts. It's a very great approach, actually. You just have to do integration by parts, but I think he's unsure because it does look very awkward. It is an awkward-looking integral. Person on the right is trying to use trig identity. Yeah, that's also another great approach too. 45 seconds remaining. Excuse me. Right now they both seem to be very stuck. That sine inverse tangent of x is very, very out of the way. I don't know how they're gonna surpass this in 15 seconds because you have to deal with that log function as well. Dang. No. Yeah. Integration by parts. Very close. Very close. Yeah, he had that secant square log sine of u. You just had to do integration by parts. It was very close. I'd probably go for that as well, like let u equal inverse tangent of x and integration by parts. That's the route I would go as well. It was a very good approach, but that secant square ln of sine got to. Yeah, it is a very scary looking integral. Yeah, they drill through a lot of integrals. No one has gotten it right so far. Really try to find a way to kind of break the tie.
Okay, so because this has been going on for a while, and the contestant on this side and integral wrong by just a factor of -2, they both agree that we give them one more integral, and if none of them solves it, then both are will qualify. So this one is this integral that doesn't fit the size. Ready?
Okay. Yeah, so we're trying with the integral. Oh my god. Oh, there's an x at the bottom. Let u equal ln of x immediately. There's an x at the bottom. Start letting u equal ln of x. That would be the immediate thing to do. Start somewhere. Right now they just want to rewrite the integral just for comfort, and then there you go. Let u equal x equal e to the u. Multi-subbing. Oh my god. Yeah, let u equal ln of x. Yeah, that also works too. Ooh. Person on the right is just trying to reformat the integral. Ln of x, ln of x. Ooh. That was a good cancellation. Wait, but then there's that U. Oh, wait. Oh, no, that U is... Okay, yeah, he's... Oh. I think the person on the left might get it. Oh, now you just have to turn it back to X. Oh, that looks right. And L11, 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 X. That's all. Yeah, that looks right. I really hope he didn't miss out on anything or forgotten anything. That looks correct.
Oh, we have an answer. That is correct.
Yeah! Very nice. Multi-sub. Very nice. That was intense. Oh my god. After so many integrals, it was very crazy. That was very nice. Instead of letting U equal Ln of X, let U equal Ln of X. Just try to get everything finished. And then there was some, turns out there were some nice, very nice cancellations. Very nice.
Okay,
Well done.
after those for the final, we now go to the next one. We have Shi against Musti, and we invite them both to the board.
Alright, we got our new 2 contestants up on the board. All right.
And we go back to the 8th final integral. Let's go.
Here we go. Ooh. Integral from 0 to 1. 1 minus x squared over 1 plus x squared squared, and then times the 1 over 1 plus x squared. Wow. That is actually crazy. I would just simplify, you know, of course we have 1 minus x squared squared and over 1 plus x squared cubed. So there are many things that you can go. I think right now the person on the left is try to do polynomial division. Oh no, he's just reformatting. The person, okay. So they're just reformatting. The person on the right is trying to find a way to make the integral cleaner. Yeah, you have to be very experimental with this integral. See which approach to take, which approach to like retreat from. Oh wow, is that the answer? Oh, did the person? Oh no. Dang. That was very quick. I was just like... Seems like the person on the left just kind of... It seemed to be just kind of polynomial division. So U sub as well. That was very quick. A quick answer, but... It was... Turns out it was incorrect. It is a very tricky integral. You have to be very experimental. You know, let x equal tangent theta, or you could also, I don't know. I would kind of let x equal tangent theta just kind of to try it out, see where it goes. But to keep it in the form like this is like very, very tricky to maneuver. Let's see. Half of t. Not enough time.
Time's up.
Dang. Yeah. Pirate 8. Oh my god. Wait, that means he was actually close. Cosine of t over 2. So what that would turn out? I don't know. Maybe. I'm not sure. That was a very tricky integral. You have to be quickly experimental with that. Let either x equal tangent theta or take a different approach. That's a very tricky integral. Alright, we're gonna start with the next integral. Ooh, a limit. A double limit? Oh my god. A double limit integral. That is crazy. From a to b approaching to 0, from 0 to infinity. E to the a minus ex, and e to the power of b minus ex. All over a minus b. Wow. So limit integrals are very tricky. A double limit integral is just a whole nother level. Was not expecting a double limit. Yeah, like I said, like you start somewhere, see where something flows. It looks like a Perlani integral, but there's no x at the bottom. But I mean, at the same time though, I mean, it's just, they're exponential functions, so you could still integrate them nicely, but the only thing is, the distracting thing is just the bunch of a's and b's in the limit. I guess a great approach is to just simply integrate it first and then deal with the limit. But right now, it seems like the limit is kind of distracting. Person on the left is trying to think how to kind of maneuver that limit. Those constants a's and b's are very distracting. Person on the right is trying to I'm not exactly quite sure what the person on the right is doing. Oh, we have an answer? Infinity. No, all integrals should converge. But hopefully it's not a mistake or anything. But all integrals here should converge. We shouldn't have any divergent integrals. Hopefully not. If we don't have them make a mistake. But person on the right is still trying to maneuver. So the person on the right did integrate it, and then they just need to find a way to compute the bounds from 0 to infinity. Because it does look weird, right? You have to consider, notice that the exponent has to be negative in order for it to converge. Because you're plugging in infinity.
And that
1 over
is
e
correct.
squared. Oh my god, 1 over e squared. That was... Wow. Came in clutch. That is amazing.
A beautiful battle between she and Lucy.
Wow. 1 over e squared. That was very nice. Holy hell. It felt like it was almost the last second. But, dang. Wow, that was amazing. came in clutch.
Both are ready?
Alright, we'll go ahead and start with
Let's
our
go.
new two contestants and the new integral. Here we go. Oh my god, another pi product. An integral from 0 to pi over 4, sine 2x, the pi product of e to the power of negative 1, power of n, and tangent x to the power of 2n. That's, I don't know how you, yeah, I just kind of simplify somewhere. Notice that that's all in exponential, so you could actually turn it into e to the power of a sum. And then notice if that's, recognize if that's like a Taylor series or something. From 0 to pi over 4. From 0 to pi over 4, tangent of x is less than 1 between 0 and pi over 4. So that means you could potentially use geometric series in the exponent. Yeah, I think that's kind of the way to go. Person on the left is trying to find a way to simplify it. See if there's a sine 2x. I'm not sure. Oh, we have an answer. Pi squared over 12. It's kind of hard to tell what he did, but the person on the right simplified it very quickly, actually, with 1 minute 23 seconds remaining. Oh, but unfortunately, I believe the answer was incorrect. It seemed like a legit answer, but no. But yeah, notice that it's an exponent. It's an exponential pi product, so that means it's an e to the power of a sum. I believe it's a geometric series. So it would be like 1 over. Oh, so it would be e to the power of cosine square. Yeah, it's tricky. Putting it in pi product form is very, just a little evilness. But, I mean, that's kind of traditional in the integration bee. But, yeah, if you simplify it, notice it's e to the power of cosine square, and then sine 2x, where you can use up, let e equal cosine square. But that's hard to see. That pi product is very scary looking. 0.
Uneducated guess, but it's wrong.
Yeah. E minus square root of e. Very close.
Move on to the next egg file integral.
Yeah. That pi product is very tricky if you're not comfortable with pi products or handling pi products. It can be very tricky.
Ready?
Alright, for the next integral.
Let's go.
We have the integral of sine of inverse tangent of x. Oh lord. Triangle or integrate by parts? Oh my god. The person on the right is integrated by parts immediately. Just trying to get this out of the way. That's actually a not bad approach, actually. Just straight up integrate by parts. But then you just have to deal with the x inverse tangent of x squared plus 1. And that just kind of comes in with another integration by parts. But I would let u equal inverse tangent of x first. And then kind of see. Yeah, but The easiest way is to use the triangle, the trigonometry standard method. But it is a very awkward looking integral. Right now, the person on the right, even though he's integrated by parts, but it's in a tricky position. You just have to make sure, you know, that person did not leave anything behind. Ooh, nice. Good catch. Yeah, when you're going very quickly, you have to be very careful not to lose accuracy. Make sure you don't miss any constants, no missing negatives, anything. That's the risk of going too fast sometimes. But this is a very awkward integral. Ooh. Person on the left has cosine. Person on the left also did integration by parts, but a little bit stuck. Oh, very close. U sub. Use tangent. Both are heavily trying to integrate by parts quickly, but we have 10 seconds remaining. Oh my god. A very long answer. Square root of x squared plus 1 plus c. But oh my god. Right now they're just gonna have to check a very long answer. See if it simplifies down correspondingly to square root of x squared plus 1. But no, that was a tricky integral. Honestly, I kind of hate those types of integrals as well, because you have to kind of maneuver. You can use the triangle too, but like that's like the easiest way to use the triangle. And then kind of simplify. I think the whole simplification was that the whole integral equals to x over square root of x squared plus 1. So then that's how you get the answer, the square root of x squared plus 1 plus c. But it was a very awkward looking integral, so I can't really blame both of these contestants.
Wrong answer.
Dang. It was an attempt. But yeah.
Time for a tiebreaker.
Alright, we're moving on to tiebreaker now.
Ready? Let's go.
Alright. Getting started with another integral now. We have the log of x plus 1 over x. Ooh. Okay. Person on the right simplified the expression inside the log. Maybe use logarithm laws. Kind of split it up maybe. Oh no. Okay, never mind. Well, you just immediately integrate by parts. Very nice. Just has to be very careful. It's hard to. I can't even integrate by parts like that mentally. You have to be very extremely careful. If you can trust yourself that you don't make any mistakes, but very impressive. I think the person on the left is also integrating by parts. Yeah. We just have an x left. Where's the derivative of x plus 1 over x? Oh, they're both trying to rush, trying to get the answer before the other opponent does. Well, they're both writing very fast. Oh my god. X plus inverse tangent of x is incorrect. Yeah, 'cause I figured the person missed the derivative of x plus 1 over x. Yeah, they forgot the 1 minus 1 over x squared on top. Person on the right is still working on it, making sure. Yeah. Person on the right has to make sure that not missing anything. Be very careful. Quickly checking their work and see if they got it. It looks right, actually. That actually might be it. That actually looks correct. XL and yeah. And then just a simple polynomial division of x and inverse tangent of x. Oh my god, 15 seconds remaining. 10 seconds remaining. Come on. Circle it. There you go. It looks right, but I'm not sure. I can't tell.
That is correct.
Wow, there you go. Very nice. That integration by parts was very fast. I'm impressed. I cannot mentally integrate by parts like that. That is crazy. And it's also very nice that he checked his work to make sure he's not missing anything. But very nice. But alright. Now, next to our other two new contestants. Wow. That was an intense match, actually. They were both integrating by parts very quickly. Very intense. Also very nice accuracy too. Make sure no constants, no negative works left behind. You could have easily missed that too. But alright. It's time for an integral for these two new contestants now. We have the absolute value from -1 to 1. 1 over 1 plus the absolute value of x to the power of x. That is crazy. Starting off with a regular round integral, this is actually I would consider this a very difficult integral if you don't know what ninja substitution is. Yeah. -1 to 0 and 0 to 1. I don't know how you're gonna deal with that negative. I mean, let u equal negative x on the first term and just get x to the power of negative x, but then what now? Oh, okay, maybe add both of them, you get 1. That's very sneaky. Yeah, the person on the right is at the right track. So close. 0! Oh! That's... dang. The person on the right was actually at the right track. You know. Just let u equal negative x and then add them together. They cancel each other out. And the integral just equals to 1. Yeah, no, this is actually a tricky integral if you don't know what ninja substitution is. Letting u equal negative x. It's a very sneaky integration technique. Person on the left is trying to find a u substitution, but I don't know how that's gonna work. It's like, you know, force u subbing. Like it's a good attempt to like experiment with, see what's going on with the integral, but I don't know where it's gonna lead to. Yeah. Pretty much the person on the left is letting u equal x to the power of x. But I don't know how that's gonna work.
30 seconds.
It's a very tricky integral. I'm surprised this integral is in regular round. We're only in 1/8 finals. It's a very, very tricky integral. We have 10 seconds left. Two minus 2/3.
That is wrong.
I think the answer should be 1. Yeah. No, the person on the right had like the correct formation. It's just very hard to see the u equal negative x trick. So close, very close. Wow. Very close. But I'm surprised they threw that integral for a regular round. 1/8 finals. It's a very sneaky integral if you've never seen that popular integral before. Very hard to see. Alright, we're going to start with the next integral. From 0 to 2 pi, inverse tangent of sine of x. Dang. They're going real evil with these type of integrals. But at the same time, it really is fair game for every contestant. But man, this is pure evil. Yeah, the person on the right is integrating by parts. The person on the left is trying to kind of reformat it in a better formation, but with a square root. Well, the person on the right is really quickly trying to integrate this. Two minutes remaining. It was actually a very great start, actually. Ooh. Person on the right is very close. Person on the left is trying to kind of reformat the integral. but it's just kind of, it's just very awkward looking. Wow. Oh, and now and the person on the left is now trying to integrate by parts. Person on the right is stuck. Try to find a way to kind of quickly maneuver it. Oh. Yeah. It's like person on the right is getting like weird results. Yeah, if something's not right, if something's off, it's good to retreat and try to start over. See where you went wrong. 30 seconds left. Both are trying to simplify this out very nicely. A small graph. Wow. Try to see which domain it cuts off. Just try to simplify it nicely. Okay, so he left the integration by parts stuff. Oh, we have an answer. Pi over 6. Incorrect. He's leaving the whole integration by parts as a reference for its indefinite.
That's correct.
Oh my god, a 0 get! That's crazy! Last time he guessed 0 and it was correct. That's crazy! Oh my god! Holy hell! The second time you just 0. And it, wow. What are the odds? That's such a miracle. That's crazy. That is crazy. Just a simple guess. It was even his second time too. Like just guessed 0, just last second, and it just turned out to be correct. That's crazy. Wow, that's pure luck. That is just pure luck. Holy hell. A very lucky guess.
Okay, so we move on to the last one. Yes, we have Serikova and Trondheim.
Alright. These are our last two contestants, I believe. I could be wrong, but we finally have both of them now. Dang. What a crazy guess. Just last second 0. That was insane. Really. Alright, here we go. We have another integral. Oh my god. Piecewise integral. Starting very difficult. A floor function of log with another floor function in its base. 202.4. With a decimal. Starting off evil already. From 2 to 22. Yeah, I kind of... Let's see. That's difficult. You have to kind of list every case. Each domain. Like log base 2 for 202.4. And then log base 3 for 202.4. And you have to kind of add all that integral up, computing the floor function of that. That's actually evil. That's a very evil integral. And I don't blame both of them. This is a very evil integral. Like it's kind of, it's not really. You don't usually learn how to deal with integrals like this, especially piecewise functions. And right now they're both stuck not knowing where to even start or to begin with. And the person on the left wrote some numerical values, kind of try to help visualize where this integral is going. But it's a very weird looking integral. Yeah, you're gonna have to start with like, you're gonna have to manually integrate this, all cases. So you're pretty much computing the floor of that log with different bases from 2 to 22. That's literally what that integral is. You just have to make sure not to mess up computing it. It's a very, very evil integral actually. Right now the person on the left is trying to kind of compute numerically, trying to estimate accurately, trying not to make a mistake or missing by one off. The person on the right is still trying to figure out how to approach it. 10 seconds remaining. Yeah, this is a very evil integral. This is a very evil integral. Wow, starting off with a very difficult integral.
The answer is the answer to everything.
42. The answer to everything. That's crazy. Oh my god. That's a very evil integral to start with. I cannot believe that. You literally have to compute every floor function of like log of 202.4 with that decimal, and then compute every base from 2 to 22. That's crazy. Alright, we're gonna start with another integral now. From x, oh wow, integral of x plus 2 to the power of x plus 2 to the power of x plus 2? You have two exponentials. I can't exactly tell. Yeah, I think it's x plus 2 to the power of x plus 2 to the power of x plus 2. Okay. Yeah, that looks non-elementary, but I mean, I could be wrong. Oh no, it's not. It is elementary. Yeah. Notice the 2 to the power of x and then plus 2 to the power of x plus 2. You just have to kind of turn it into in product form rather than exponential form, and then you should realize that letting u equal 2 to the power of x. Yeah, and that's exactly what the person on the left is doing right now. The person on the right is just trying to carefully u-sub it without making any mistakes. Both are trying to carefully u-sub it. And you have to also be careful not to miss the ln of 2 at the bottom. Oh my god. It's integral of 16 to the power of u du. (16 to the power of u) from the I'm not quite sure. The person on the left's boxing the answer already. I'm not sure where the 16 come from, because you can't really square the base 2, because it's 2 to the power of x. I'm not quite sure. Oh, it is correct! Oh my god! That is crazy. Wow. Look how excited. Wow. That's amazing. I'm just wondering where the 16 comes from. That's crazy. Holy hell. Yeah. Letting you go to the power of X is the way to go.
Best of 3 or most out of 3, as I explained in the beginning.
Alright.
So we move on to the first quarterfinal. Livestream against Pool.
Yeah, so that's about it for the 1/8 finals. Now we're moving on to 1/4 finals, quarterfinals. Integrals are still 3 minutes per integral, but this time it's going to be best out of 3 instead.
Sorry. Another thing we were requesting before the event, the quarterfinal where Gary Plummer is should again be first because he has an appointment soon. I'm sorry. And then we move on to this one. So we have Ramberger against Beagle.
Alright, we are beginning. Seems like we are beginning quarterfinals. Are we? Yes, we are. Ooh. Things are about to get more intense now. Seeing how difficult the integrals kind of were for the regular, for the 1/8 finals.
Both contestants ready?
Alright.
Okay, let's
We're
go.
about to see our first integral for quarterfinals. Let's see what we have. Oh my god, the integral of 0 to infinity, inverse cosine over 1 plus x squared times inverse secant plus inverse cosine of x. That's a very weird looking integral. Plus inverse secant minus. How would you even? Oh, wait. No. 0 to infinity? Right now they're both trying to kind of... They're actually both approaching this very quickly, actually. I wouldn't even know how to even approach this. A ghost symmetry? I don't think you can ghost symmetry that either, because it's 0 to infinity. There's no negative inversion. I don't know how inversion would help. Yeah, they're both trying to figure out how to approach that integral, because that's a very weird looking integral. Inverse secant plus inverse cosine of x. But then you have that 1 plus x squared out of nowhere. Maybe is that assigned to let x equal tangent theta? Maybe? But then you have like inverse cosine of tangent theta. And the rest in terms of tangent theta, I'm not sure. Could be a King's rule. Is that what it's trying to go for? Oh, because inverse secant of 1 over x is inverse cosine? Is that what that is? If you do Queen's rule, so x equal tangent theta and then Queen's rule might do the trick. So you end up with pi squared over 4 as the answer. Well, that's very hard to see. Right now the person on the right is trying to kind of simplify everything. X equal log. No, I don't even know how you would go about this. Both are still trying to find an efficient way to speed integrate this, but it's... that's very difficult. Okay, right now they're just trying to... 20 seconds remaining. Person on the right is still in progress, but the integral is looking weird. 10 seconds left. We might have a guess. pi over 2. Pi over 4. Oh my god. Pi over 4. It wasn't pi square over 4. It's just pi over 4. Wow. I accidentally said pi square over 4. No, pi over 4 is what I meant. But dang, so close. If he would have answered pi or guessed pi over 4, dang. Again, just the sheer luck. But pi over 2, very close to the answer. Off by 2 integers in the bottom. But no, that's a very difficult integral to see. I think that's how you approach this. Let x equal tangent theta and then Queen's rule. But the identity of knowing that inverse secant 1 over x is inverse cosecant is difficult to spot. And now we have our next integral, an infinite function, 24 times. Okay, so not exactly infinite, but there's a pattern here. So I would start generalizing. And I think that's what the person on the right is doing. That's a very good start, yes. Square root of 1 minus x squared. Very great start, and now you just have to kind of know where it stops. Is it cyclic? Is it not cyclic? Or where is it repeating? Oh, is there ambiguity? It looks okay to me. The integral doesn't seem to have any ambiguities. But ooh, you have to check where. You have to kind of find a pattern. See how many times where it cycles. Okay. First on the left is integrating by parts again. They just have to get it very quickly. I mean, they have a good amount of time. They have a minute, more than a minute. They have a very good start. It's just so now it's just all about accuracy. Ooh, that was very close. And the person on the right is also integrating by parts as well. I can't tell. Zero. No. Yeah, because that's not. It's an even function, so it can't be 0. There's no way. Right now the person on the left is just carefully integrating by parts, making sure, you know, kind of doing a domain check. 2024. Sine of what? No, it's just 1. Wow. So that means that the whole function simplifies to... Oh my god. Dang. Yeah, you'd have to kind of generalize and see where the cyclic function, see the pattern.
Move on to the third final integral. Now, since this is small, solve for 3. If someone gets this right, they qualify.
Okay. So yeah, because this is the third attempt now, whoever gets this integral right will move on to the next round. They don't have to exactly get 3 integrals right. It's just this is best out of 3. And we have an integral from 0 to infinity, e to the negative x to the power of 1 over 3. So a cube root. It looks like a cube root. Yeah, cube root. Oh, that looks like a gamma function. Let's see who's the fastest to recognize it. Right now, they're both. The person on the left U-subbing. I think the person on the right is also U-subbing as well. But ooh. Oh, an integration by parts? Looks like integration. Oh no. Okay. No, the person did do a U sub, letting x equal a u cube. Yeah, that's a good start. And then they should be able to realize something. Oh no, integration by parts, I guess. That's still a good way to solve it. I'd integrate by parts quickly before the opponent gets it. Right. Now it's just a matter of whoever gets it first. Because they're both at a very right track. They're both very close to the answer. It's just who's gonna get it first. From 0 to 1 is 0. Person on the left just forced you sub to everything. Forced U substitution. Well, does that work?
Stop, that is correct.
Oh, there you go. 6. Very nice. Holy hell. Very nice. Yeah, it's secretly a gamma function. It's 3 factorial.
Who can now go to disappointment, and you can see him continue competing
Three times 2 factorial, technically. But, wow. Very nice.
Okay, we continue the usual order, right here against good.
Yeah, let u equal, let x equal u cube, and then you'll notice, recognize a gamma function integral. Oh, wow. Alright, now we're gonna move on with our next 2 contestants.
We have Ogoroma Chop here.
Damn. Sheesh. Haguroma chop. The highest quality.
Ready? Let's go.
Alright. Here comes our upcoming integral. Oh my god. Again, just trying not to get problem shocked. Just start somewhere. Simplify something. Like the sine of x plus pi over 4 and the sine of x minus pi over 4. Like, what is that? Like, what is that identity? Turn it to something. And then kind of realize what is going on in this integral. You know? Best thing to do is just start somewhere. Trying not to get stunned by these long functions, but man, the cinch and the coach is throwing me off. Right now, both are trying to start where to even approach this effectively. Yeah, the 1 plus sine 2x. Notice that 1 plus sine 2x is equal to sine x plus cosine of x squared. So maybe there's something to do with that sine of x plus pi over 4 and sine of x minus pi over 4. There's something. And there's cinch and cosh, so there's a little suspicion here, right? Maybe that's a reverse product rule, but who knows? Let's see if they're gonna catch that. But right now they're both trying to simplify it. And then 1 plus sine 2x is not really a well-known identity, so I don't blame them if they can't spot it. But yeah, the person on the left is trying to simplify that. those two identities in terms of sines and cosines. First on the right is okay, so he's planning to go turn it into exponential form. Just have to be very careful. It doesn't lead to a trappy route. Both have 1 minute remaining. Then going full out exponential. The thing is, how fast can you do it? And then that 1 plus sine 2x is out of the way too. So I don't know how that's gonna. I don't know. It looks very distracting. The person on the left is still trying to simplify the identity. Both have 15 seconds left. Very difficult. Ooh! Sinh sine of x. Incorrect. Sinh cosh. It does look like a reverse product rule integral. Ah, cosh over sine of x plus cosine of x with root 2. Dang. So it's a reverse quotient rule, to be exact. That's very hard to spot. Yeah, you have to be very quickly experimental and be fast at recognizing. But no, tricky integral. We're gonna go ahead and start off with the next integral now. Just kind of cleaning the chalkboard. I'm so used to whiteboards. I'm not really familiar with. I don't really use chalkboards, but. Just starting an integram. Alright. We go for the next integral. And we have a sum. Wow. The sine of x plus 2k pi over 2024 dx. Again, you have to be quickly experimental. Kind of construct it, or not construct it, deconstruct it. Turn it into a sum, see where this is going, find a pattern. And then, you know, see where this is leading, where does this lead up to. Right, notice there's a 2 pi. So there must be a pattern here somewhere. But, I don't know. This feels like one of those Math Olympiad problems where you simplify and it's like by angle that, you know, x plus something is equal to sine of x or something like that. Kind of like a reflection rule. That's what this sum is giving me. It gives me that kind of vibe, but I'm not sure. Right now the person on the left is trying to simplify it as well. Is deconstructing the sum. A great approach. If there's an awkward sum, you always deconstruct it and try to figure out what is going on in the sum. The person on the right is also just trying to figure out a way to manipulate this. But it's a very tricky sum. It's really out of the way. One way is you could just integrate it and then do the sum, but I don't know if that's allowed. But this is very tricky. Ooh, okay. Yeah, something like that. That's what I was thinking too. The person on the left is seeing a pattern. Things like that. Right. The beginning terms is equal to the ending terms, maybe. Off by a 2 pi minus something. Yeah, that kind of pattern. That's what I thought too.
30 seconds.
That could be wrong. Right now the person on the left is just trying to use as much trig identity as possible, trying to manipulate this, but that's weird. The person on the right is trying to graph, see what's going on, but no. Not enough time. Guess, maybe? Oh wow, it's indefinite. Yeah, time's up. Yeah, that's a very difficult integral. Negative cosine of x plus c. Wow. So they all add up to sine of x, simplified. Dang. Yeah, that's a very tricky integral. It is kind of a math Olympiad style, but yeah, very tricky. Holy hell.
Okay, we move on to the third. Remember that since it's 1 out of 3, this can be decisive if one of the contestants solves it.
Alright, here we go. Going on for the next integral. Again, best out of 3. Whoever gets it, we'll move on. Oh my god. And here we go with another difficult integral. A piecewise integral. Finding the min of AB integers and A less than B. Oh my god. That is hectic. I would start off by what's in the exponent? A floor of x over A, x over B. I don't know how you would graph this. Yeah, I start plotting because it's a weird. Plotting might help, but how would you go about this? Notice that it's for AB integers. For AB integers, they want the min of that integral for any AB integers. Yeah, graphing is a great start. It's a very great start. Try to visualize where the values are and where to integrate under the curve, but I wouldn't even know how to go about this. This is a very weird looking integral. Piecewise integrals like this, especially like with min, like it's very, very tricky to maneuver. There's nothing but to be forced to graph or to kind of have a good understanding of function. 0. A good guess, but not quite. It is looking for the min, but yeah, I don't blame him. I don't know how you would even approach this. Yeah, notice he has to like make 2 graphs trying to visualize, make an accurate graph. You know, it's very scary to graph in integration bees because again, you're in a time limit. You have to kind of speed graph. Make sure you're not messing up your graph, as well as trying to integrate as quickly as possible. From A to B though. I don't know if there's a pattern. I don't know how you would sum this up either, because you can't really do a U sub. Or -8.
Only would be -4, but the theorem is 24 symmetric. So you basically get the
Oh, okay, so he was on the right track then. It just kind of missed something. Dang. That's a very difficult integral. A very awkward piecewise integral. Piecewise integrals are always hard. They're not always easy.
0-0 after 3 quarterfinals, so we move on to the tiebreaker, which can be decisive.
Alright, so we're gonna move on to tiebreaker now. But yeah, not every piecewise integral you could just use the sum. Sometimes you have to actually manually integrate it. That was a very tricky integral.
All ready?
Alright, moving on to the next integral.
Let's go.
Oh my god, integral cube. Oh, simplify immediately. You know exactly what to do. Simplify immediately. Yeah, they're both going at it right now. Trying to. Let's see, we got tangent of x. But then you have tangent x. Oh, we'll go tangent x. Tangent square? Oh no, tangent cube. That looks like an integral tangent square though. Yeah, that can't be correct. Yeah. That's for an integral of tangent square. I think this one's a tangent cube. Dang. Very close, very close. But you gotta be very accurate. Cotangent? Oh yeah, that's right. Yeah. It would be the integral of cotangent cube instead. Very good simplification. Good accuracy. Now you just have to integrate cotangent cube. Yeah, if you're not comfortable with integrating in terms of cotangent and cosecant, you could also turn it in terms of sine of x and cosines. It's just a little bit more tedious. Yeah, because you have to do the u substitution and then dealing with negative exponents as you do power rule. Yeah. There you go. He's at the right track. 1 minute 25 seconds remaining. Very good position right now. Now he just has to be very accurate. Make sure he doesn't mess up. Now just be careful not to miss a negative or any constants. Yeah, that looks right. If you're turning everything in terms of sines and cosines, that looks like the right form of integration. Ooh. And right now he's checking. Yes, he has a good minute to just check, make sure nothing went wrong. Not missing a constant. It looks right to me, actually. Yeah. That looks right. 15 seconds, come on, you can circle it. Oh! Oh no! 3 seconds. Oh my god.
That is correct.
Nice! That was very nice eye catch. Holy hell. Very nice eye catching. Last second. Oh my god. Yeah, you gotta be very careful. That's the only risky thing is just missing a negative or constant. Yeah. Negative exponents, you be careful with power rule. Holy hell, that was very nice. Amazing check of work. Wow. All right. Continuing next. Man, that was crazy. It was last second too. Last second check. Very nice.
Okay, we start normally with 3 quarterfinal intros.
All right.
Are ready? Okay, let's go.
Here goes our next integral. Ooh, integral of dx sine of x plus sine square. This was actually tricky. Notice there's no cosine that you can use up with. So you have sine of x times 1 plus sine. Yes, very nice. Start somewhere. Factor. Zero substitution is actually very nice. And person on the right is just quickly decomposing. Ooh! And we have the person on the left already have it nicely decomposed. Now it's just integrating in terms of we have to integrate cosecant x and then minus 1 over 1 plus sine of x. It's just how familiar are they with cosecant? Okay, that works too. Yeah, Weierstrass substitution. You just have to be very, very careful with integrating. Try not to mess up your algebra or anywhere, miss anything. But Weierstrass is one way to go. I believe the person on the right is still partial fractioning. There you go. Also using Weierstrass as well, looks like. With T formulae. Oh my god, they're both going at it with Weierstrass. Trying to see, now it's just, they have 1 minute left, so now it's just about who can get it first. Or hopefully both of them don't miss anything. Because Weierstrass is a little risky if you're not very accurate or careful enough. Oh! It looks like the... Oh, I think I got it. Ooh!
Stop, that is correct.
Nice! Very nice.
It's not over yet, it's almost out of 3. So
Yeah, it's best out of 3. That was just the first integral. So, best out of 3. So there's a chance for the other opponent. But yeah, the partial fraction is, you know, partial fraction decomposition is just kind of slowing a little bit down, but wow, that was very nice. Okay, so now we just oh,
And now the second
there we go. Now for our next integral.
You're both ready?
So now here we have sinh x plus cosh x. All over 20 sinh plus 24 cosh. Ooh. This looks very scary. We're both trying to, let's see. Okay. 20x. Yeah, I don't know how that's... This looks like one of those linear algebra integrals, but the person on the right is trying to turn everything in terms of exponential form. And hoping that it's easier to like perform U sub or something with. I think the person on the left is actually trying to do the linear algebra method. Or just controlling the numerator to try to kind of decompose it, turn it something, simplify it easier, but I don't know how you're gonna go with that. 4 sinh of x? Oh, okay, I see what he did there. He's trying to integrate this quickly with exponential form, but you have to be very careful because now you have like a quadratic exponential integral-ish, and with all those coefficients is very nasty. That x over 24 is actually a very good start. That's just, now it's just kind of distracting. Yeah, now it's a simplified integral, but what now? You know? Okay. Weierstrass? Oh no, that's not Weierstrass. Oh, he's U-subbing the exponents, and now 1 over 22. He's integrating fast, trying to... Ooh. That was actually quite fast. Right now they're just trying to judge whether if it's in the correct it's the correct answer. 1 over 44. I wasn't expecting that exponential form to simplify that nicely. I don't know. You might need another. I can't tell. It doesn't. I couldn't imagine it to simplify it like that nicely. Because all those coefficients are like very. They're not very nice numbers. I don't know. Yeah, it is incorrect. Yeah. Okay. Dang. It was a good attempt though. Turning an exponential form isn't actually... It's actually quite good if you trying to simplify everything. It's just the only risky thing is you have everything in terms of like a rational polynomial that you have to integrate with nasty numbers. Yeah. 5 seconds. There's no... I don't know. That's very tricky. Yeah, that looks like a linear algebra integral. Yeah, I figured. Dang. Very tricky integral. I think. Yeah, you have to kind of... You have to convert the numerator in 2 different forms. One term where it's the same as the denominator, and then the other where the numerator is the derivative of the denominator. And you have to find coefficients a and b, which would match. But
now since it's already 1-0, this integral will very well be decisive.
we're gonna go for another round, I think. Wow. Alright, let's get ready for another next integral. We have integral of pi over 6 to pi over 2. Sine 2x cosine x all over sine x plus cosine x. Ooh. Now it's all just in terms of manipulating trig now. Trig manipulation. No, if things like this, like it's very awkward, especially the denominator like sine x plus cosine x, I would convert it into a different term of trig functions like in terms of tan x and secant x. I know they're both trying to figure out a way to manipulate it, but I would just conjugate it into a different, in terms of different trig functions. Yeah, I would convert it in terms of secant x and tangent x, but I think they're just trying to find a way to manipulate it. Oh, and now we're gonna get into Weierstrass. Excuse me. Weierstrass substitution. That could possibly work, actually. You just have to kind of be careful not to miss anything. First on the right is still trying to trig manipulate it, but that denominator is very distracting. Or it's just out of the way. Yeah, I would just kind of convert everything in terms of secant x and tangent x. Experiment somewhere. They're both trying very hard try to get it in the simplest form possible. I think he's still trying to figure out a way to manipulate it, but oh my god. In terms of x plus pi over 4, huh. But how would you deal with the numerator? Okay, we got some cancellations, but still, we still left with like some ugly, yeah. It looks like an ugly function to integrate using Weierstrass. Kind of somewhere along. Yeah. Less than 10 seconds. 5. Yeah, that's tricky. Very tricky integral.
So we have our third semi-finalist.
1/4. Okay. There we go. We did have 1-0, so. Wow.
Now I will have to disappoint you. Last time we had some serious repercussions because we went over the time limit and we only have the room for 15 minutes left. That's why, if it's okay with everyone, we decided to move the last quarterfinal to tomorrow when we have way more time because we have very few matches.
Yeah.
Otherwise, we might never get this room again if we go over the limit again. So I'm really sorry.
I think that's all of our all of our semi-finalists. That concludes it for this just for today. So tomorrow we'll start and continue for semi-finals and finals round. That's where things will get very, very intense. So yeah.
Everyone, even though they lost today, because we will give the certificates, we will have an actual
Wow. Anyone who's still watching it, thank you guys so much for coming by and watching our integration beat at Vienna. It has been very intense. A lot of the integrals here are very difficult, surprisingly. But you know, if you want to see some even harder integrals at semifinals and finals round, you know, stay tuned tomorrow. We'll start exactly same time, 11:30 a.m. at Central CST time. Yeah. Yeah, thank you guys for coming in. Thank Vienna Integration Bee for inviting me to commentate. It's a great pleasure to watch, and yeah, I think that's about it for today's Vienna Integration Bee. Last things before I make sure. So I'm just gonna show the brackets. Yeah, they are ending. The bracket round. We do have. This is what we see of our conclusion. So tomorrow again, we're gonna start doing our semifinals and finals round. Same time, 11:30 a.m. CST Central. And yeah, thank you guys for coming, and I'll see you guys tomorrow. It's gonna be very, very intense, so stay tuned. All right. All right.
Geschafft haben. 3 Stunden plus Wie lange war die 2 Stunden? Keine Ahnung. Ich glaube, wir müssen ruhig anders machen.
All right. I'll see y'all tomorrow. Stay tuned for the most intense integration bee.
Yeah.